So we're going to look at formulas 4 to 6 today. And the first identity, it's basically, it's just an identity we're trying to prove. Cos of A minus B equals cos A cos B plus sin A sin B. Now what we're going to do here, we're going to show that, we're going to find the distance between this point and this point. In other words, what's the length of that line? And we're going to find it in two different ways. The first way that we're going to find it is using the cosine rule. So here we have a triangle. So using the cosine rule. And then the second way we find it is using the distance formula by just taking these 2 points as coordinates and finding the distance between them. Now, so if you look at this, so let P and Q be 2 points on the unit circle. Now, the unit circle is the key word there. That means that the radius of the circle is 1. Okay, so the radius of the circle is 1. So that means that, now of course, this is the angle. So if that's the angle, then if that's the angle A, then that's the side A. But what size is that angle there? Well, whatever size A is, let's just say A was 120. And let's just say B was 40. Then that angle there would be 120 take away 40. That's where this is coming from here, the size of that angle. So just using the cosine rule, A squared plus B squared, sorry, A squared equals B squared plus C squared minus 2BC cos A. Now, so B and C are 1. So that's 1 and that's 1. A is the distance from P to Q. So P to Q, that's A. So there, A squared is PQ squared. Now, so that gives you an expression for PQ squared as 2 minus 2 cos A minus B. So that just gives you an expression. Now, the next point of it is we're going to use the distance formula to find the distance between cos A sin B and cos B sin B. Remember, any point on the unit circle can be represented as cos A sin A. So that's in your tables. It's on page 13. Any point on the unit circle can be called cos A or sin A, or sorry, cos A sin A. So the next part then is get the distance formula. So label the points. So cos A sin A, they've labelled that as x2, y2. So x2 minus x1 squared, y2 minus y1 squared. Now squaring these out, suppose, so you square the first one. Oh, sorry, what they've done is they've taken the square root across and they've got pq squared, which is exactly what we have up here, pq squared. So then they square the first, which gives you cos squared A, multiplied the two of them together, and doubled it, and squared the last. And the same here, square the first, you get sin squared A. Multiply the two of them and double it, gives you minus 2 sin A sin B, and then square the last, gives you sin B squared. Now, so what they've done here then is they've put cos squared A plus sin squared A, so this sin squared A, they've moved it closer to here. And remember what cos squared A plus sin squared A is equal to? It was our first identity. It's equal to 1, and it's in that table again. That's an identity. Cos squared A plus sin squared A equals 1. So they've replaced this with 1. Now they've also done cos squared B and sin squared B, so that'll also be equal to 1. And then they have 2 cos A cos B minus 2 sin A sin B. Okay, so that's what they mean there by formula 1. They mean by formula 1 on the other page, they've replaced cos squared A sin squared A with 1 and cos squared B sin squared B with 1. So now I have another expression for PQ squared. And remember, if PQ squared equals this, and PQ squared equals that, which they've labelled 1 and 2, then that means that 1 and 2 are equal to each other. So they let the two of them equal each other. So 2 minus 2 cos A minus B. So the 2's divide, and then divide across by minus 2 on both sides, and that gives you the proof that you needed, or the proof of the identity. Now that's quite a difficult one, but there's just 2 steps to it. Number 1, they found the distance between the 2 points using the cosine rule and the distance formula, and then they've equated them. Now that's exactly how you do the fifth one. The 4 and 5 are nearly 2 for the price of 1 because it's exactly the same method, except when you get to this very last step here, see this very last step here, you replace b with minus b, okay? Because then that gives you a minus minus b, which gives you a plus b. So what they've done, so then they replace b with minus b, and they replace b here with minus b. And just something to remember also from your tables, although we haven't really done a lot of it. There's just a couple of rules here. Cos of minus a is equal to cos a. So in other words, cos of minus 30 would be equal to cos of 30. Sin of minus 90 would be minus sin of 90, and tan of minus a is minus tan of a. Those are identities, so they can be put in there. So what you see with what we have here, cos of minus b is the same as cos of b. So that's why that's changed there. And sin of minus b. So sin of minus b is minus sin b. So then plus sin by minus sin, that's where this minus comes out of. Okay, so that's it done. Just at the end, if you're asked to prove this one, just at the very end, you work formula 4 the whole way to the end, and then you replace b with minus b. And the third one, the last one that I want you to look at today, although we have this one done from a different one. So cos 2a equals cos squared a minus sin squared a. So we know from this is an identity on page 14 of the tables. So see it there, cos of a plus b. So we're trying to show that. So replace, so basically in cos 2a, what if that was, sorry, you can't see that there. So cos, what would cos of a plus b, what would happen if a was equal to b? Then it would just be a plus a, which is cos 2a. So that's why we use that identity. We just let a equal b. And we let a equal b. So cos a is cos squared a, and sin a is minus sin squared a. Now I want you to look at these three between now and tomorrow, and then we'll go on and we'll do 7 and 9, although we kind of have 9 done anyway. Maybe 7 might require a bit of attention.